Hello, it's Cliff here from Down Under. In this video I'm going to talk about D-bit grinders or single lip cutter grinders. Mainly I'm going to be talking about grinding wheels, diamond grinding wheels and hubs. I've just completed a production run of hubs or arbors of 10 little hubs that allow me to put the wheels on and off more quickly. I've watched a couple of excellent videos from Rob Renzetti and Stefan Gottswinter about D-bit grinders, and they've suggested various little attachments and tools and methods that really inspired me. And I've got a couple of new designs in here as well, which hopefully will add to the collective knowledge. A little shroud to put over your dial indicator so that you can check the concentricity of your wheels, and a process using this arbor. I trialed a process for refurbishing old and worn and wobbly cheap diamond grinding wheels, and it works so well. Please stay on and have a look at it. If you're interested in diamond grinding or D-bit grinders, there'll probably be something useful here for you. Cheers! I want these wheel hubs for my little universal D-bit grinder, a sort of a Deckel clone, and the machine is really good value for money, made in China, and the quality's not too bad, but it only came with one wheel hub, and so every time I needed to change wheels I had to install the wheel and centralize it and dress it, and it sort of put me off using it really. Anyway, after watching a couple of YouTube videos, it gave me the enthusiasm to make my own wheel hubs or arbors. They also outline a really useful little tool that saves time with installing and extracting the wheel hubs or arbors, and this all helps you to speed up the use of the machine and make it more likely that you will utilize it fully. Here's the D-bit grinder available here in New Zealand from Machinery House. It's on sale for $14.34 New Zealand dollars. That's about $1,000 US dollars. The arbors are $60 US dollars. That's about 40 US dollars. If you're interested in the production of these 10 arbors that I've just made, I've done a video on it called CNC Lathe Job Setup and Run. 3 parts of 3 videos. Have a look at those videos if you're interested in the manufacture of these arbors. I've got plenty of these little 4-inch grinding wheels, diamond wheels, and a whole selection of cup wheels. The problem is it just takes so long to set them up, centralize them, get them running true, dress them and so on, that you tend to not bother. And so if I've got them set up and true on their hubs with the little quick installation and extraction tool, I'll make much better use of the little D-bit grinder. Well, all done and ready to go. Love making things like this. Get a real buzz out of it. Back in the old days, diamond grinding wheels were really expensive. You know, a tool room would have one diamond grinding wheel and it cost several $100s, and tool makers were scared to use it. You know, I always wanted a diamond grinding wheel for my home shop, and I bought a couple of second-hand ones and they were expensive enough and really on their last legs. And then I realized that the Chinese were starting to make them for reasonable prices, and I brought a few in and bought the little D-bit grinder, but I was disappointed to see how poorly made they were. The grinding wheels were running out all wobbly, and it's very difficult to do precision work when your grinding wheels are not running perfectly true. And so I started studying different ways that you can dress the wheels to fix this problem, and there's different solutions. when it's mounted on the grinder using stones and little special grades of metal that you can use to strip the wheels down and clean them up and improve them. And I found that that sort of partially worked, but it didn't work well enough to completely refurbish badly wobbling wheels or loaded up or worn wheels, and I really wanted a way to completely refurbish it. So I did a bit more study, and anyway, one night I was lying awake and I came up with this plan. I decided I'd spend a few hours and do a big experiment, and the next day I set up the machinery and experimented with this process for fully refurbishing substandard diamond grinding wheels, and it just works so well. Please stay on and watch the following clips that explains this process. If you're going to buy a D-bit grinder, or you're already involved in D-bit grinding or diamond grinding, this could be really helpful for you. I made a little arbor so I could hold my grinding wheels in a lathe or in a milling machine for a couple of reasons. One of them is in the lathe so I can machine the body of the grinding wheels concentric. Some of these cheap Chinese diamond grinding wheels, the bodies run out quite a lot, and that causes an imbalance in the spindle and vibration. Also, I can check the grinding wheel face, and I'm not going to contact the grinding wheel face with a dial indicator because that's going to cut a flat on it very quickly. But I've just made up a little cover, a little shroud out of a piece of silver steel, drilled a little hole in the end, the diameter of the tip, and a bigger ball on it. And the idea of this is to go over the dial indicator stylus, push down until it contacts, so it's located on the stylus ball end, push it down on the taper until it bites into the taper, and now we have a sacrificial cover or shroud, is it? So I can now check to see how much out the face is, because that really wants to be concentric. That's not as big a run out as the actual body, but still it's, you know, a couple of thou run out, about 5/100ths. So I think I can see a way to get that concentric as well. So while I'm at it, I might as well upgrade all of my grinding wheels and machine the bodies. Quite a small job really, and it'll make things go a lot smoother in the future. Just looking at a couple of the tools that I use for this project. For the dial indicator cover, that little cover there, it doesn't need to be anything flash because you're only going to get flats worn on it anyway. So it's just a little sleeve with a hole in the middle. There's a sectional view of it there. So it contacts on the ball of the stylus down in the depth and pinches on the taper up near the end. So it's contacting at 2 points. Seems to work really well. I haven't bothered polishing it into a nice little sphere because it's just going to get flats worn on it anyway. And that's the arbor there. So it's just important that it is that this little locating spigot, 20 millimeters for the grinding wheel, is concentric, and that flat surface there is at right angles to the main shaft, the shank that goes inside the lathe or the milling machine. Let me show you the grinding wheel body run out. So that's nearly 0.3 of a millimeter, you know, 11 thou run out. That's a serious imbalance and vibration to the grinding wheel spindle. So I can tip the top slide round on the angle and just skim that true, and I bet the insides out as well. So I can get that all running true and better balanced, and then I've just got to work out a way to dress the diamond wheel nice and concentric and sharp. Well, here's the arbor here, just to show you it's quite accurate. So that's running concentric there relative to the shank. You can dial it in with these chucks. I've probably heard me raving on about this. I've got adjustable chucks. And equally important, needs to be concentric on the face as well. It's just a rough surface finish, but it's running pretty true. Have a look at the run out on this one, it's shocking. Well, that took a millimetre, 40 thou to clean up. Okay, the big experiment. This is my diamond wheel dressing setup. I've got no idea if it's going to work, but I want to show you the run out to start with. This wheel's got a run out of about 0.1 on that face, about 4 thou. We've got an oil stone in the vise and we're running it really slow, and if this works I'll explain to you how it works, and if it doesn't work I'll probably delete the clip. I think this is going to work. Let me show it to you in action and then I'll have a look at the end results. So I've got an old woodworking oil stone for sharpening chisels and plane blades, and we've got the diamond wheel which had a 4 thou run out on the face. I'll just run the machine now and show you in action how it operates. So put some kerosene on the surface. So you can hear from that noise that it's cutting evenly. It was cutting intermittently, and you can see from the colour that it's removed some of the diamond wheel bonding. So it seems to be working. I'm getting two benefits. I'm dressing the old rounded oil stone flat again, and I'm truing up the diamond wheel. Let's take the diamond wheel out and have a look at it. So it's running true now, and I was only doing it for a few minutes. You can see it's registering the roughness of the wheel, but it's running true, and it's true in line with the axis. So we've trued up the wheel. Let's pull it off and have a look at it. Well, look at that, it works. I'm slightly excited here. Found a way to dress the hardest of all materials, diamond. And you can see the greens come off on the stone and the slurry over the wheel. And look at the finish on that wheel. It's beautiful now, and we know that it's running true and concentric, and it only took a few minutes with some kerosene on an old woodworking grindstone. And let me try and explain why I thought this would be worth trying. I did some study on the internet and heard of a couple of similar examples of people dressing diamond wheels, and I began to realize that an oil stone can dress a diamond wheel in certain situations, because the abrasive particles in the oil stone, although they're softer than the diamond, if you get the feed and speed right, the abrasive particles get in between the diamonds and cut the bond out. And if it's set up right, it will cut the bond out enough for the diamond to be unsupported, each little diamond to become unsupported, and they'll fall out. And so the soft carborundum stone or aluminium oxide or silicon carbide stone is hard enough to cut the bond and erode away the diamonds. And does it work? It works fantastic. And the other thing about this method is that not only do you fix the run out and the bluntness and the carbide and metal loading in the surface of your carbide wheel, you refresh it back to probably as good or better than new, but you're also resurfacing the surface of your oil stones. And I can get some of my old oil stones and grind them in flat, and it seems to cut the oil stone slightly quicker than the diamond wheel, but I probably did about 10 passes of a few thou each pass, and that cleaned up 3/4 of the surface of the oil stone and even cleaned up that 1/4 thou run out of the diamond wheel. So maybe about a 4-to-1 in favor of wearing the oil stone and 1 in favor of wearing the diamond. So that's a really efficient process for resurfacing both parts. Just going through some of the details here. I'm running the spindle as slow as I can. It's about 70 RPM. I'm using a woodworking stone. That's a bi-grit stone. One side's fine and one side's coarse or medium. I've got the medium or coarse side to the top, and I'm using a diamond wheel of about 150 grit. Now this cutting ratio and effectiveness may vary from different grades of oil stone and grit ratios to different grades of diamond wheel, but I've got a feeling this is going to work across a wide range of situations. Well, let's try it on another grinding wheel. So this grinding wheel is a 320 grit, the one I measured before, and it's got a run out of about 5/100ths, about 2 thou. It's a 320 grit wheel, and this is a coarse wood tool sharpening stone. It's probably a grit, I'm guessing, of 1 or 2 or 300. It's not the fine side, it's the grey side. The fine sides are sort of a rose colour, and that might be 5 or 6 or 700 grit. So this side's probably 1 or 2 or 300 grit. We'll leave that one uppermost and we'll try it. Alright, let's fire it up. We're putting a bit of kerosene on there. We're trying to avoid getting any of this grit on the machine because it's going to be a mixture of diamond and carborundum or silicon carbide. You can hear it starting to cut intermittently when it first comes into contact, so I'll stop yapping so you can hear. You can hear it not cutting intermittently now. It's already running true. Wow, look at that surface. It's running true and it's beautiful. It's a generated flat surface. That's the best part about it. You're generating a flat surface on the diamond wheel and you're generating a flat surface on the oil stone. Believe it or not, both are being achieved simultaneously. So what's happening is the oil stone's taking the bond out between the diamonds, and eventually the diamonds become unsupported and get ripped out into the slurry, and the diamonds are cutting down the oil stone at the same time. So one is assisting the other and you're getting the perfect end result. Well, I doubt whether I've invented something here. This is probably common knowledge among some specialists, but it's certainly new to me, and probably a lot of you guys will be able to use this to dress your diamond wheels and your oil stones. Well, the slurry is getting close to overflowing, so I've taken it off the mill. I really don't want to get any of that on the machine. Now let's have a look at it. So you can see the oil stone is now beautifully flat. And there's the two wheels, the 320 and the 150 grit wheel. They look really good. So if there's any specialists or experts that know about this subject, please post in the comments below. I'm really unaware of what I'm doing here. It's just been a big experiment, It may be that there's some downside. There's usually a downside to a successful procedure, isn't there? I mean, maybe this is toxic, or I know it's highly abrasive because it's a mixture of the most abrasive stuff. I don't know what that green is. It's probably just a dye. But please let me know in the comments below if there's anything unsafe about what I'm doing here. So I've mounted it up on the grinding wheel now, and it's looking really good. It's averaging within 1/100th of a millimeter, just a flicker because of the movement of the setup on the abrasive surface, but it's really concentric compared with what it was, and we've got the body running true as well. Success! Well, I'm wondering now whether it will work for dressing the outside diameter of an OD diamond grinding wheel. So I put this one up. It's running a long way out, about 0.25, about 1/4 of a millimeter, about 10 thou, and I've got a different oil stone in the vise. It's literally a $2 shop oil stone, a real junky one, but let's just see if it works. Okay, a few minutes work, and look at that, running beautifully true. So I ended up by using a slightly different feed rate, more like that, so a faster traverse, more like when I was using it on the face wheel. I realized I'd cut down the feed rate. So because we're not machining something to get a good surface, we're trying to rip the bond out from between the diamonds, and so we need a fast movement in both directions. Otherwise, I suppose the diamonds will just cut away at the stone and we'll get nowhere. But this has certainly worked well with that quicker travel. And we have a lovely concentric, smooth, round wheel, and it would also work really well for removing any loading or bonding, you know, when you get little metal particles in the surface, or when it gets all out of shape. This has got so much potential. You can see that $2 shop wheel has worn quite significantly on the end. Maybe it's a really cheap and nasty wheel. Maybe they put beach sand in it as well as the aluminium oxide. I'm going to try this face wheel now that I got with the grinder on the machine. I'm not sure what grit it is. It's running out about 7 or 8/100ths of a millimeter. It's about 3 thou, and we'll see whether that junky wheel will dress the diamond wheel. Well, that $2 shop stone seemed to work all right as well. Didn't cut quite as fast, but I've got that running true now. And I did the outside diameter via that method previously, and that was running a long way out, like 1/2 a millimeter out. And now I've got that running true as well. You can see the quite big slurry of diamond wheel there in that brown color. So, you know, this is working. I don't think it's cutting quite as quickly as the better quality woodworking stone, but you know, it does work. And so if you're on a budget or you don't have a stone handy, you can pick up a $2 shop or a $1 probably in the USA, $1 shop cheap oil stone, and it might take you a few minutes longer. You might wear more of the stone away, but it does work. Let's have a look at the use of this tool. So we put the Allen key end in first, and we can loosen the little screw that's holding the wheel and arbor onto the spindle. And that's the little screw and washer there. I also used a little hardened washer to save damaging the internals. And now we're going to use the other end as a jack screw, and it's got a long spigot that goes down to the bottom of the hole, so we're not jacking on the surface of the thread, which is likely to damage it. So that just jacks it off, and you can remove it. You can see that there. So as quick as that, you can replace your grinding wheels with this little tool. Well, there's some great ideas on YouTube, isn't there? I got the idea for this little wrench for assembling and disassembling these wheels. You can zip them on and off really quickly with the jack screw on one end, the Allen key on the other end, and handles in the middle. This is brilliant. The manufacturer puts out this 2-pin wrench to tighten up the wheel nut, but this is even more useful and it's not included. Anyway, I'd highly advise everyone who has a D-bit grinder to make one of these. There's a drawing if it helps you. You can pause your screen, take a screenshot and print that off. So you can make it like this without doing any welding. Really easy way to make it. It's just a piece of, what is that diameter? 10mm shafting in the middle. I screw in a piece of a screw, extend the thread slightly, turn it down. It's an 8mm screw to that shape. Screw it in with a bit of Loctite. So that's that end taken care of. The other end, cut a piece of an Allen key off. Now here's the trick, and these are refined dimensions. I didn't quite get it 100% the first time. If you drill a hole in the end a little bit smaller than across the corners, it's about 5.6 across the corners. So if you drilled it about 5.2 would probably be better. And just turn in the lathe the corners off for the first couple of millimeters down to that 5.2 diameter. That would act as a guide. Then you could push it in that couple of millimeters, put it in the vise and just shear it in. It would just cut the corners in. I gave it a bit too much and it almost split the shaft. So you just need a few thou of interference so that the hexagon key would cut its own little hexagon inside there. Anyway, this has worked fine, but it's just a little bit too much of a heavy fit. So there we are, a very useful little wrench that you can make very quickly and easily without doing any welding. Just want to talk briefly about diamond wheeled grit size. If I look at the little brochure that came with the machine, it talks about the wheels supplied with the machine, but it doesn't mention the grit size. I bought a couple of grinding wheels from AliExpress and I got a 150 and a 320, and if you catch it in the light you can sort of see the little diamonds shining in the light. The spacing of them on the 150 is definitely, they're smaller and finer on the 320, and the same on this diameter one, it's a 320. But I don't know what the grit size is of the wheel that came with the machine, but it looks the same sort of spacing and sparkle as the 150, so I'm guessing it's about a 150. So that could be quite useful for you guys to try and work out what type of grade wheel you've got. I've listened to a few YouTube videos and people are using all different grades, 400-500 grade wheels cut with a finer surface finish, but they don't cut as aggressively. I found that these work quite well at 150, although the finish is probably not that great. Again, you're generating it to some extent, so you can get away with a fairly coarse wheel. I'll be using this 320 now that I've got the Arbors, and I'll be able to figure out whether that's a better grit for multi-purpose work or not. Well, now I've got 6 grinding wheels mounted on their Arbors, sharp and running true. This is going to be so much more enjoyable. I've got a worn down, good quality, non-fiber reinforced Noritake cut-off wheel. They cut like magic. It's still slightly big. I need to dress it down to the 4 inches, and then I can mount that on an arbor, and I'm going to have so much more enjoyment from my D-bit grinder now I have this added capacity. Well, thanks for watching and visiting my shop. Cheers.